So, hello guys, and good day once again. So, I think because of time issue, we are just going to start right away. So, other guys will join us as we proceed. So, I'm also privileged to have been joined by some of the team members from African Center for Data Science and Analytics Limited, and they'll be ready to respond to any questions that will be directed to our PCDSA team members. So our guest today is Daniel Musyoka. Daniel Musyoka is an assistant manager, customer experience and analytics at Airtel Kenya Limited. Daniel has experience of about 8 years in IT systems, analytics, business intelligence, and data science. He also has vast experience in data engineering learning. Problems. So today we are going to privileged. We're going to hear from him on opportunities that are available for data scientists in the Kenyan market. So I think I'm just going to shift it right away to Daniel, so he can introduce himself better, and then just comments. Thank you guys. Welcome, Daniel.
Thank you, Dirk. I hope you can clearly hear me from this other side of Lob. If you can't hear me, you just type some comment so that I know I'm being listened to. So thank you very much, and I'm happy to have this opportunity to have a chat, which was requested by Abraham and his friends. And I start right away with an introduction. So my name is Daniel, as you've seen we've heard from Dirk. And I've been dealing with data for the last 8 to 9 years. And I have vast experience with, having taken several roles. And these roles involve data engineering, business intelligence, application architect, developer, and I'll take you through a presentation to see how these roles fit in to a role of being a data scientist. So I can see we have a lot of members, and I would just start right away with my presentation. So, Ondir, please let me know if you can see my presentation.
I can see from my end.
Okay.
Yeah, it is visible.
Yeah, it's visible. So I'll invite everyone to go to www.menti.com and use the code above there, because I want to present you with some questions and some interactions to be able to understand the kind of people I'm dealing with, or the kind of forum we are dealing with. And then I'll go through some presentation about data science, some of my journeys, and we'll spend a lot of time in Q&A, where you will have an opportunity to ask me any question, and then I can be able to take you through, some of your questions and answer some of the things I'm sure you're looking to hear from us. So if you are at www.menti.com and you've keyed in the code, which is 28122016, you'll be presented with a question above there. I just want to know the education background. For data scientists, you have you can come from different, backgrounds, which can be computer science, data science, actuarial. I know we have some graduates from who have taken actuarial science, biology, etc., health, and anything. So please type your education background, and we'll be able to see the background of all the members who have joined today's forum. I just give you like a few seconds to get answers. So we have one person from mathematics, applied statistics, actuarial. There is electrical engineering. There's another actuarial. Anyone from computer science? There's mathematics. So I'll give you like 1 minute so that we move forward very quickly. So I'm interested to know if there's anyone who is outside the common education backgrounds which relate to data science. For instance, anyone from health, biology, tourism, etc., etc. I think that's it. From what I see, most of the students are from applied statistics, actuarial, electrical engineering, mathematics, which is a good thing. Before I start my presentation, I'll give you one quote which comes from the book referred to as Factfulness by Hans Rosling, who says the world cannot be understood without numbers, but the world cannot be understood with numbers alone. So this means that you can have numbers with data, but still you need some domain expertise to be able to use your numbers and to interpret the problem you have at hand. So you can feel free to interrupt me if you cannot clearly hear me, specifically your Dirk. So I'll just proceed and show you why, the reason as to why we are discussing this topic today of data science. I want to take you through the journey of why do we require data scientists? And later on, we'll see how big is, or how many roles is a data scientist going to tackle as a data scientist. We'll see some of the experiences, some of the roles, and I share my experiences throughout my journey of what I've gone through to be able to call myself a participant in the field of data science. So if you look at how things have been in the last 10 years, you see that data has grown exponentially from the year 2010 to up to date, which is 2021. And there's an influx of data around 2014. And this is the time when there was introduction of smartphones, Internet of Things, and data. We started collecting data from all walks of life. And that posed a big challenge where, data scientists were not able, us as human beings, using the traditional methods of processing and storing data, we are not able to process that kind of data and extract insights from it. So we also combine the power of machines, and still we were not able to process 50%, even 50% of the data we are collecting from all the walks of life. So recently, there was introduction of machine learning, which now leveraged the power of teaching machines to understand data and do a lot of computations and mining, and from that extract the full potential of the data we collect from all these devices, all the data we collect from different sources. And you can see, if you combine data scientists, all the traditional ways of data science, with machines, this is now, when I talk of machines, it's the traditional way of building softwares with logics of if, else, to process data from instructions which are being provided by humans. We still cannot process half of the data with such instructions. So we need more. So there we did an introduction of machine learning, which has now blown everything to its potential. And now let's now look at a very confusing way to present data science. We will talk about the roles and how to differentiate different terminologies which are being used interchangeably. For instance, AI, machine learning, deep learning, there are all these kinds of terms used in the world of data. And to understand how to place each in its own place. If you start talking about data science, you realize that it's a combination of several things. The power of mathematics, the power of computer science, understanding of domain expertise. And if you combine two of them, for instance, domain expertise and mathematics, you will basically be doing statistical research. If you do computer science and domain expertise, this is data processing. And that's what traditionally people have been doing. Or experts in a certain domain, you use some power of computing, like building softwares, CRM, etc., to process data. Then if you combine now statistics or mathematics, the power of math and statistics and probability and algorithm with computer science, you build powerful models, and that's what's now referred to as machine learning. And the combination of all these disciplines, it's what we refer to as data science. And there are some roles which are closely related to a data scientist. For instance, throughout my career, I've worked either of these two roles, being a data engineer and data analyst. And data engineer, it's very common in each and every organization, because organizations have been collecting data and storing that data in their data warehouses, or for instance, in databases, in form of silos. For instance, if you go to big organizations which have different departments, these departments keep data separately. If you want an insight touching different departments, then you would require skills for a data engineer to build data pipelines and join all these different data sources together. So a data engineer is a very important role when it comes to a data scientist. A data analyst is now experts who are using maths and statistics and algorithms to do what we call data communication. For instance, you're given data sets in Excel and you create some analytics from that data set without using a lot of power for extracting data from different sources. So data engineers also leverage what we call big data, and we'll touch a lot around that. And the other confusing terms is between deep learning, data science, machine learning, and AI. And you'll find that AI is very wide, and it has been used in the last couple of years. But this term, came into life most recently. And I'll give you two main branches of AI. One, which is strong AI, which is mainly focused on building systems which mimic the human. For example, the Deep Blue machine by IBM, which defeated Kasparov in playing chess, that chess expert. Robots which can walk, and all these things which you see in the movies, fiction movies. But machine learning, which came up recently, is now, sorry. I hope you're good. Okay, so machine learning, which came in recently, it's what we call focused AI. It's what's called focused AI, where you use machines to solve a problem in a certain domain. For instance, if you're trying to predict the number of customers who are going to churn from your business, or you're clustering your customers. So that's a specific problem in a specific domain. And it will leverage the power of AI, but specifically using machine learning. And deep learning is a sub-branch of machine learning, where now you for instance, think about the deep neural networks. I'm sure there are people who are studying a lot around machine learning. And deep learning is now focused, but inside the machine learning field. And all these, you find that when doing artificial intelligence, machine learning, and deep learning, you'll be practicing inside the field of data science. And we'll go in deep with this in the Q&A, where I'm sure you have questions we can answer and better understand what we are saying. So moving forward, I just want to show you some of the basic skills, both soft skills and technical skills you may want to have for you to become a data science. And one is, you need programming. Like I said to one of my colleagues, for you to become a data science, it's going to be so hard for you to deal with data without some skills in programming. And we'll see some of the languages which we can use to easily manipulate data, Python being one of them, which I'm sure every one of you have heard about, people talking about Python in left, right, and center. The other thing is communication and domain knowledge. For instance, if you get into a company, personally I have worked so many years in the domain of telecommunication. If you move to banking, it's a bit different. So you need some communication skills to be able to learn a lot from that domain for you to tackle a data science project. And the other one is presentation. And this is around, if you're dealing with stakeholders, you have to present some results. And I'm sure we will later come up with another webinar, maybe to discuss about how to tackle a data science project A to Z. The other one is real life practice. Sorry, you need to do a lot of practice in data science and have creativity and other things like machine learning, neurocomputing, data mining, and these are skills which are learned, and it takes a lot of time to gather all these skills, and mainly it's done through experience. So we now ask ourselves about which language do we use? Do you use MATLAB, Octave, R, Python, or Java? So I came up with a few insights which I got it from a book which talks about the data science career, which gives us an insight of when to use which kind of a programming language. And I picked the top 4. Some companies use MATLAB, others use R, Python, Java, and some of those companies will also use either or join two languages, Python or Java. And I just picked the way that the book discusses about it. When to use MATLAB, for example, and you find that MATLAB is a software which mostly it's used by engineers, and the engineers in this forum can attest to that. And this is mostly, you use it when you're working with data which is presented in a form of matrices. Or for example, if you know a particular add-on or a package, particularly in MATLAB, which is of great use. But if that data is not in matrix form or in table form, it may be a little bit challenging for you to use MATLAB. And the other major drawback which is discussed is if you want to include your code in a software which is going to be sold. So it may be a challenge to use an idea of MATLAB in certain project. When it comes to R, R is a language which has a lot of packages. And if you're working in academia, for instance, in bioinformatics, social sciences, or you want to load and pass data and manipulate that data a little bit faster. So R is a good programming language to use. One thing which is interesting and which I usually discuss with my colleagues and friends is be careful when you're using R because it has some license implications. For example, if you want to package your software and sell it online, you may want to read through the implications of the license. And if you are creating a production software, it's a bit challenging to, package your software and put it in production. And you see that is handled easier in a language such as Python. If you want to use object-oriented architecture, R it's also not great. Now, when it comes to Python, where if you compare all the programming languages currently used by data scientists, Python is one of the best and one of the most used in the field of data science. And it works well if you want to productionize your software. If you're building a prototype, some application, and you want to put it on a production, Python provides you with a package to package that software and build an API, because it's a language which has been there supporting software development, and it has all these ways to build APIs, and you're able to push your package into production. Another good use of Python would be when you're learning machine learning using natural language processing. So there are kits for NLP which are built under Python. If you're integrating with other software, as we've said, in production you have all these sorts of different softwares written in different programming languages. So it's easier to work with Python. And if you are working in a lot of non-statistical programming, that's another great way you could apply Python. Although it has its own challenges, if you work in a field where maybe the developers are using a different program, so you may want to consider using the same language the programmers are using. Another thing is, if you have packages which are available in a different language like R, and they are not in Python, then you can choose to go there to not use Python in that case. And the other thing is, if you are generating graphs, plots, etc., if you've worked with R, you'll find that R gives a better visualization tools or packages in that case. Then the other one is Java, which I've worked with in enterprise environment. So if you want to create a robust and portable software, because most of the people are already familiar with Java, and it has a lot of capabilities, and we know that billions of devices are already running in Java. And this is one of the things I faced in my experience, where you build something with Python, but you're not able to put it into an enterprise server, because that server does not give you rights to install Python's software. And with Java, because the engine is already running, it's easier to, so I had to convert my code from Python to Java. And some drawbacks, of course, if you're doing a lot of exploratory, I find it easier to use R in that case, or Python or R. And if you don't know much about Java, the learning curve of Java, it's a bit complicated. So you find most people, it would be easier for them to start with a soft language such as Python. And if you don't really need a software which is robust, like in cases of hard hoc requests, you don't need to start building a complex application using Java in that case. Then I share with you my approach, and I would appreciate if either Joshua or one of the members say hi to know we are still together. Ondiek?
We're still together.
Thank you very much. So these are some of the skills which sorry, we're still together? Thank you. So I just share my approach. And then after that, we go to questions and answers. And this is all the skills which I was able to gather throughout my experiences, working with companies such as IBM as an application architect, dealing with programming languages, dealing with building data warehouses and migrating data applications. So one of the major skills which is very important when you're doing data science is hacking skills. And this is hacking in data, joining the power of different programming languages to achieve a certain goal within the shortest period of time. For instance, if you are presented with a certain small piece of data, it may be so complicated to use only one programming language to achieve your goals. And this occurs in the first phase of data extraction and data wrangling, preparation of your data sets. You'll require skills of Shell, SQL, Python, R. And if you're able to join all these programming languages into one project, then that's a great skill called hacking in the field of data science. The other thing is mathematics and statistics or probability for data science. And this is basically the mean, median, and the graduates, most of you who come from Actuarial or statistics, they'll be expert in that field. But for data science, there is that statistics which is specific for data scientists. The basic probability, it's a good thing to have an understanding of how math can be applied and to do some modeling using, for example, things like Bayes statistics of inference. The other thing is, which is very important, is data engineering and dealing with databases. In every data project, you will find yourself building either a big or a small database to hold your data. It's not easy to manipulate large data sets using Excel or some basic statistical packages, such as SPSS. If you're presented with data up to 100 million records, then you may have to build a database. So a good knowledge in databases, data engineering, and this comes with ETL, what we refer to as extraction, transformation, loading. If you have data which qualifies to be big data, then you need some skills in Hadoop and Spark. And this big data, you remember the main 4 V's of big data, volumes and variety and velocity and veracity. So if you have that kind of an environment handling data which qualifies to be big data, then you require skills such as Hadoop and Spark. And if you research, Hadoop came in fast, but both Hadoop and Spark use the MapReduce technique to process large data sets. And Spark seemed like it's 10 times faster than Hadoop, but each has its own place for application. Then it's important to learn SQL databases. I've learned Oracle, Postgres, DB2, and as well as document and NoSQL databases, MongoDB, Elasticsearch, Cassandra, Dynamo, Redis, etc. The other most recent technology, which is very important, is data streaming and dealing with QA technologies. And data streaming is, dealing with data in real time. For instance, if you want to capture all the tweets from Twitter into your system and do analytics around that, you need some streaming technology. And one of them include Kafka, which is a tool by LinkedIn, if I'm not wrong, Spark, and also other technologies which do queuing, like RabbitMQ, ActiveMQ. So these are very important technologies which you need to equip yourself with. And the other thing is data analysis and BI, being able to interact with the business and provide reports, dashboards, and do some visualization for both all the stages of management. You know very well that visualization can be during data exploration, or it can be after you've completed your data project and you want to present the results to the stakeholders. So visualization, reporting, and business intelligence is very important in your career as a data scientist. And some of the tools which I've been able to interact with is Kibana, Grafana, Tableau, Power BI, as well as Python and R. So Python and R, you see, it has very good packages for doing a visualization. And then, very importantly, machine learning or artificial intelligence and data mining. And this is now building the models. And this comes after you've collected your data, put it in a data warehouse where you need data engineering and data warehousing skills and skills to deal with databases. And now it's time to build your regression, clustering, classification, recommender systems. During that stage, you really need these kind of skills in your career. And the other thing is cloud computing. Most companies have not been able to manage data centers. It's very expensive and tasking to set up a whole data center. If, for instance, you're running big data technology, it will take a lot of power, a lot of money, costs to set up the entire environment. So it's a good thing and a good skill to have, a very wide knowledge in dealing with cloud computing. Most commonly, Amazon, Microsoft Azure, IBM, and Google Cloud. Then the other skill is Devops. And this is important for machine learning engineers, where after you build your model, you want to put, for instance, you have a website which is already running, and you want to present some recommendation to this to people who visit your website. And these recommendations are based on a machine learning, a model which you've built using either R, Python, or whichever language. So you need to leverage the power of DevOps tools. You may package that in containers. And then all these other skills, of dealing with containers, for example, container orchestration using Kubernetes, and continuous development, integration, code versioning, you all need all these skills to be able to push a certain project to production. And API is also another skill which you need to have, dealing with SOAP, REST, GraphQL, to have your applications integrate well with the solution you've built using your machine learning, or maybe a data science project you want to put into production. And then, most importantly, data governance and security. And this comes in, we have a lot of data compliance acts. For instance, the recent one for Kenya Personal Data Protection Act for, I think, 2019. So you have to be careful when dealing with data, specifically personal data. Otherwise, you can face a lot of fines and cost you a lot. And other things like data accuracy. You need to ensure that the data you collect is accurate. And you have these data management skills, ensuring the correct data set falls into the correct hands to avoid data misuse. And in your project, it's important to do documentation. Set up data wikis to explain all your data sets, or what we call data about data, metadata of data, ensuring if you share with your team, they're able to, continue your project or understand what it entails. And most importantly, like I say, data ethics and compliance. Then the other thing, in any data project, you'll be interacting with different applications, and you need some basic understanding of IP networking and security, how firewalls work. And if you go deeper, to do a few pen testing, where you can do penetration testing on your application that you've built, or your data project, and see whether malicious hackers are able to penetrate your project. And I think that's it. That's what I went through until currently for the last 8 years. So some of these skills will take a lot of time to learn them, and you have to be patient, and look into the correct sources. So now, if you look at your screen, you're now presented with some choices, and I want to know, which role do you think is cool from that presentation? We have BI, a big data engineer, BI developer, BI analyst, visualization developer, machine learning specialist or engineer, data scientist, data manager, research scientist, decision scientist. So pick one of the role you think is cool, and let's see the results. We already have two. We've already picked data scientist. Another data scientist. You only have 5 votes. Machine learning specialist and engineer. Great. Another machine learning specialist or engineer. So let's take like 3 minutes and please choose, so that we move to the section of Q&A. There's no one who wants to be big data engineer or BI analyst. So I think I would relate to the results which I'm seeing right now. And this is because most people think,
Hey,
hey, yes? I think somebody is trying to ask something. I didn't get it.
I was asking, where are people typing from? Where are people typing from?
So
Where
go
are people
to
choosing from?
you go to menti.com. So visit www.menti.com. It's on your up here, and use that code.
Okay.
Yeah.
Okay. Thank you.
Okay. So menti.com and use the code 28122016. you'll be presented with the challenge. And let me give you another 1 minute for the ones who joined a little bit later. So as we are streaming these results, I would relate with the way there was this introduction of data science career in the last, I think, 4 years. And then I was working as a BI analyst and doing, working in the role of application architect, building data warehouses, mostly data engineering and dealing with data. But the aspect of machine learning had not, seen the light, where what I mean is most people had not gotten the idea of how machine learning, and it did not have a lot of courses and degrees offering machine learning. So I would say that I became a data scientist a long time ago, because data science in itself involves so many roles. Even being a visualization developer, you can turn yourself as a data scientist. Wow, there's a BI analyst there. And this, you realize that whatever most companies are looking for as a data scientist, they will only achieve that by having an entire department with people playing different roles. And these roles involve the roles you are seeing, including big data engineer or a data engineer. It will be so hard for you to become a unicorn. This is what we call a unicorn in the field of data science. This is a person who has all the skills, from domain expertise, data engineering, math and statistics, machine learning, data mining, visualization expert, and good presentation skills, good communication skills, creativity. It will be so hard for you to achieve all those goals. Otherwise, you can achieve them, but it's going to take you a lot of time to be experienced in all these fields. So what I advise people when they're looking for, you don't sit back and wait until a company advertises a job as a data scientist, because they will look at the role, and you'll find that the way it's framed, they will require some skills of a data scientist. For instance, some companies will require an insights and analytics manager who has some skills in data engineering and visualization and data warehousing skills. Some companies, however, will be specific where they are looking for machine learning engineers or machine learning specialists, where these engineers will work with data scientists. Let me just call them data scientists or decision scientists for this case, who build models, test them, check if they give the best performance. But we need a machine learning engineer who has software skills, software development skills, Devops skills to push that model into production. There are some companies who will look for research scientists. And these are mainly people who have PhDs in that particular. They have PhDs in a particular domain. We have also decision scientists. So all these roles overlap. And when you're looking for a job as a data scientist, don't only go looking for a data scientist, the name data scientist, because big data engineer plays a big percentage of a data scientist. A data manager as well, visualization developer. These are people who are experts in building good visual representations, and they will be very good in developing presentation using Tableau and using all these presentation softwares. And they can leverage results or insights with user stories and present that to the stakeholders. So I think now we go to the next very important section for questions. And if you are at menti.com, you'll be presented with a place where you can type any question. So I'll be waiting for your questions and I'll answer them as they come in. Any questions? Please type, and you can also feel free to unmute yourself and ask a question. Okay, there's one question which goes, how can you model an actuarial problem using machine learning? And what skills do you need there? So first, to build any model, you require data. Unless you already get presented with cleaned up data sets. So you'd find yourself, manipulating different data sets. And let's discuss the 5 stages of a data science project. The first 2 involve data engineering, which is data collection and data preparation, acquiring data and preparing data. So the 3rd stage is now modeling. And this is where the question falls. So you need skills such as, if your data is in a database, you need skills such as SQL. If your data is big data sets presented in raw format, you may need some data cleanup skills using programming languages such as Python and Unix, or Linux, or Shell. If your data is in big data, you will require some big data skills to process that data. So this question can fall into different stages. If you're presented with clean data, then you can go straight away to write your machine learning models using Python or R, or using any, there's many different proprietary softwares which also can, for instance, Data Science Studio. You can also use that to model your data or to build your model. So you need all that. If you want to go a stage ahead to do presentation, you may require other skills like communication skills, of course, and presentation skills, building visualizations using Tableau, Power BI, or any software which provides a presentation or visual presentations. So I think I've answered that. So the other question is, with the introduction of AutoML models, does it mean companies will no longer require more machine learning engineers? Yeah, that's a question which has been asked by a lot of machine learning engineers or data scientists. And this was posed by one of my friends, where some companies like IBM have tools you can click and upload data on the cloud. It processes your data models it, gives you predictions, or runs whichever kind of algorithm you want, gives you the best performance, and does everything for you. But still, there's some basics where, to answer this question, if you work in any environment, in any organization, you'll find that data is not always presented to you as clean data. So machine learning, throughout my experience, is like that last stage where you have gone through 90% of work trying to prepare the kind of data you are to use to do your predictions. You have to understand the business domain. You have to understand the kind of data you're dealing with. And you can't leave it out, the stages of data extraction and understanding your data. Now, coming to the machine learning engineers, there's some companies which will require, or there will be some requirements in some of these. For instance, if you are modeling some algorithm to predict people who qualify for a loan, in some countries, it will require you to share some insights on how you achieve that. And this will not allow you to go for a black box. So yeah, AutoML has been there, but it works better for engineers who have already an experience working specifically, writing, codes to build those actual models, which can be done automatically by AutoML. So I may not answer your question well, but it's also a question which I'm also looking forward to do some research on where we are heading to. Of course, things keep on changing every day, and it's the same question we ask ourselves as we asked ourselves some years ago. When computers come, will they replace jobs for some jobs? Of course, that will happen, but it will be replaced by new challenges, which will not leave out machine learning engineers in the entire picture. So moving to the next question. Is a data scientist the one above a machine engineer? Is the data scientist the one above? I think he means the machine learning engineer. So as we've discussed, machine learning engineer can also be called a data scientist, because data science also involves machine learning. So I think there's an overlap between machine learning and data science. So it depends with the company. There are some companies who will employ a data scientist to do machine learning. There are some companies who will specifically look for a ML engineer to do machine learning. Sorry, I think someone unmuted themselves. If I wanted to ask, I didn't catch that. So I'll move to the next question. So I've been studying data science and ML for a while. I've practiced on the skills I've gained, but I feel that I haven't gotten the industry experience required. Where can I really get real hard world problems? Yeah, this is one of the challenges we face with, for instance, graduates or someone who has been doing self-study in data science, but the company they are working in, they've not yet started to, leverage the power of data science. And this can be achieved through taking online challenges. Most people go for cargo.com and, take some data sets there and work on them. However, the challenge is the data presented in cargo.com or some of these online, competitions, they are cleaned up. And I'll tell you, in the real world, you'll not be presented with a problem where the data is already cleaned up for you. So what I usually suggest to people is look for a problem you are interested in. For instance, you may think of a project which interests you, like, for me, agriculture, and start collecting data from everywhere. You learn data collection skills for instance, you can start collecting data about weather, prices, and work with passion on that project and put it on, for instance, GitHub for people to comment about it. So that's where it comes to be very important to form a community where you can work together in some projects. It may not be a project you're presenting somewhere, but most of the companies, when you're doing interviews, they look for something you've done. And it really adds on, becomes an advantage if you have, like you, done a lot of learning or studying in data science, if you have some extra project you've worked on. The other thing you can do is there are a lot of companies who can allow internships. There are some companies or organizations which can take pro bono consulting. So I think the questions are coming fast. So I'll try to answer a few questions, and we have like 1 minute. Then all the other questions we get a kind of a follow-up and answer that through a forum. So is AI a threat to humanity now that we are seeing creation of humanoid robots? So I'm not sure about that. So that's, I'm really experienced with weak or focused AI. So like I said, we have two kinds of AI. The strong AI, for example, for building robots and, you know, chess players, and we have focused AI. So I would only answer what is focused on, you know, the focused artificial intelligence. But it's something we can research about. For I to be data scientist, is it a must to have some skills in ML? So I wouldn't say it's a must, because you can choose to be a data scientist to do a visualization, to be a visualization developer, or a BI. But it's a good to have. So the answer, it's a good to have. In fact, it's a good to have all the possible skills for a data scientist, the ones we discussed before. How different is data science we study from what is expected in the industry? Yes, so most industries have their own ways of working, in their own. For instance, you will study Python, but you can find yourself working in a company which is using a proprietary software such as MATLAB. So it's the same thing as if you're in the world of IT, you shouldn't limit yourself in only one technology. So it's good to always, you know, research and learn a lot in different, you know, different fields. So in the industry, it depends with which kind of an industry and how they've quickly adopted the new technologies. And most importantly, in data science, very few industries have gone full blow into applying machine learning models. And most of industry that's still struggling with data cleanup and bringing data together, because there's that challenge of data in silos, different departments having data, and it needs to be brought together. So you can find yourself working on a company where you never write a machine learning algorithm, because the challenge presented currently is only to clean up data. And we mostly have, you know, data, because in the last several years, people have been collecting data without thinking about the structure to process this data. So we have a lot of dirty data in the industry, which needs a lot of cleanup. And it's one of the major challenges. So how do one transform Jupyter Notebook to production field data? So it depends with what kind of project you're working on. I'll just give an example. For instance, if you're training a model, you may choose to use a Jupyter Notebook if you want to do collaboration with your fellow engineers, where Jupyter Notebook allows you to put notes and give like a kind of a documentation of your work. But if you're putting that model into production, you may need to package it in a form. You may need to use some framework. For instance, there's this common framework for Python use called Flask to put it into production, because most of the times we'll have to build an API to interact with your pre-existing systems. So I'll take only 2 minutes. Are you in a position to tell us one project you've implemented at Telco using data science? I will not discuss specifically or share my current project we're working on, because of data ethics and all that. But generally, what I've spent my life doing is doing data cleanup and all these aspects surrounding data engineering. Like 2 years ago, it's when I started, building real machine learning algorithms. Mostly, the basic one will start with predicting churn. Every industry wants to know the customers who are going to churn. So that's one of the things we will find in telcos. And telcos, specifically talk about the major KPIs is to ensure customer retention. Yeah. Where can I start my data science journey? So I leave that to Joshua and Odiek. They will give you an overview of where you can get skills. For instance, Python, R. They have very good learning courses in Africa Center of Data Science and Analytics. So I hope Joshua will take the chance to give a basic idea of how to begin the journey. Is data science applicable in field of agriculture? There are models in machine learning that are already in practice, or is it a better field to study in? I can see you're excited. So personally, I've not came across big projects in agriculture, and data science is applicable in almost all the fields. So it's a good place to venture. Personally, I'm passionate about agriculture because I've built some projects in agriculture. And I would invite you to join the field, and if we can have a conversation and see where we can move with that. So it's a good field for me to study in. For a young and upcoming data analyst, is it possible for me to be mentored by you and some analysts you may know? Yes. So I'll share my contacts and you can get in touch. I'll be happy to do mentorship. Which tool is more powerful in visualization between R and Python in data science? So it depends. Both have very nice packages. For instance, Python, it depends with the experience you have in both languages. But from my research, R has better visualization packages than Python. Although Python is coming up very quickly, and you have tools every day released, which may beat R. So both, I would say, have their place to be applied. But yeah, it's a question we should look at. And if it's indeed a threat to humanity, what are some of the measures we take to mitigate the catastrophe that may arise from that? I see this is based on the previous question of whether ML, machine learning AI, is a threat to humanity. So I'm not sure about that. So maybe you can get a follow-up and answer that question, because I'm mostly focused on weak AI, which it's only helping humanity to, for instance, predict the efficacy of a vaccine. So my question is, how do we integrate all the skills into one package? And how do we have to go through each unit individually? So skills are better learned through practice. So you may learn a new language, but if you don't put it in practice or do a certain project, then it may not be easy grasp all the skills, because when you do a project, you get a challenge and you improve a lot in that area. But what I can encourage is to take as many projects as you can, both pro bono and online competitions. You really build skills through taking a project end to end. For me, because I've been in the industry, I've gotten my skills through facing all these challenges and building solutions. Which company is looking for data scientists in Kenya? Mainly offering internship. So a lot of companies are looking for data scientists. Although, like I say, don't only sit back and wait for the term data scientist. We have different roles which play as a data scientist. For instance, BI analyst, BI visualization. And it's good to take different roles and have your passion towards becoming a data scientist later. So with this, we can still get in touch and try to work together to look for companies which are offering internships and jobs. And this comes with having connections, both LinkedIn and through these forums. So I'll be open for people contacting me, and we'll be sharing the opportunities we get from all walks of life. And I think that's the last question, and it's the end of my presentation. So thank you for your time. It's my first webinar with you, and I hope I'll get comments and some insights on how to improve and have a better one next time. So without wasting a lot of time, it's now 9:10. I'll go back to Ondiek, the moderator, to take it from there. Thank you.
Okay, thank you so much, Daniel, for your generosity, which you actually demonstrated by taking a time out of your busy schedule to share such great insights on the field of data. So, I think I'm going to grant Xavier 1 minute so that he can share with the audience on how they can enroll at RPCDSA for the courses.
Okay,
yes,
thank you so much, Paul. And more specifically, Daniel, I know that you have a busy schedule, and as you are looking at your profile, you must be a very busy person. But I appreciate the fact that you are in a position to be able to join these participants to give more insights. So in form of thank you. In form of maybe trainings, I just want to echo again what Daniel has said, is that even based on the projects that we do for our customers at African Center for Data Science, is that every problem or every kind of work comes with a new challenge, unless if you get a similar task. But the importance of knowing these tools is that you are aware on where you can start doing it. It is easy to refer and so on. So basically, we have some programs at African Center for Data Science, and we have given our contacts. You can always send a WhatsApp message to us or call us, and we will be in a position to guide you on our trainings and more information, at least to assist you, to give you more insights to kickstart your journey, so that you can be in a position to know where you can start. I think it is still a new field that many people have not yet understood, but I appreciate that Daniel was in a position to dissect, if I can call, or to elaborate more about different kind of data science, machine learning roles, and so on. Because as Daniel has said, is that some organizations need, we normally call full stack data scientists. You are a machine learning engineer, you are a data scientist, you are what? So all those aspects and so on. Even for us, based on our own experience, when we get the projects that we normally do, we never use one tool. it depends with how it comes. Sometimes some projects, even Excel that people underrate, is very powerful to do other kind of projects. So it is good to have that wider view. We have some projects that are more powerful when it comes to data management or wrangling than Python and so on. So at African Center, we are able also to take you through. And also in someone wanted internship and whatever, currently the program that we have been having is that we have been taking some university students. We have some universities that we have partnered, at least those who have some knowledge about it, because it became, at one point, it was very difficult to train, to give some tasks to some artists who did not even know what is Python, what is R. At least you must know something, even how to write a simple syntax, then it becomes easy for us to take you to where you want. So that is all I had, Paul, unless maybe Daniel has anything to comment before now Paul can close for us officially.
Thank you. I think you've said it all. Skills you get from different projects. And that's how you build your toolkit. And also for internships, I think the question has been answered. We also need some kind of, an interview and look at what kind of a passion this person have. And, whether you qualify. So most companies will also take you through an interview process to qualify you to be an intern. So thank you.
Once again, thank you, Daniel, for that elaborate presentation, and also Xavier for that clarification. So I think at this juncture, I'll just beg to adjourn the webinar. So thank you guys also for attending.
Thank you.
Thank you, everyone. Thank you.
Contact. Thank you, Mr. Daniel.